This video is sponsored by Enhanced NeoAt, a company focused on next-generation battery technology and advanced powertrain components. Now with that out of the way, what's up everyone? We're currently in Chonburi, Thailand, and tonight we're testing something that might surprise a lot of people. This is the Tesla Model 3 long-range rear-wheel drive. And it could very well be one of the most efficient electric vehicles on the road today. Not only that, but it's also one of the longest-range EVs currently available, especially when you factor in real-world efficiency rather than just lab numbers. This particular Model 3 is equipped with the newer, upgraded 82 kilowatt-hour battery pack, which is expected to deliver extremely low energy consumption under steady driving conditions. That's exactly why we're doing this test. We're heading out for a nighttime range and efficiency run to see how well it performs in realistic conditions, idealized ones. Even though it's technically winter here in Thailand, winter here feels more like summer in Norway. Temperatures are warm, roads are dry, and conditions are about as favorable as you can reasonably expect for an EV test. Before we even get moving, just take a look at the color on this car. Tesla really nailed it. Under street lighting at night, it looks incredible, and it genuinely stands out without being flashy. Now, as usual, I should mention that we're not alone in the car. We've got the family with us on this trip, which means extra weight. The back seats, we've got 2 child seats installed. One is the Cybex Cloud T, and the other is the Oris T2. Combined, these 2 seats add about 30 kilograms of extra weight. There's nothing in the trunk, nothing in the front, and no other cargo on board. That extra weight from the child seats shouldn't have a meaningful impact on efficiency at cruising speeds. But it's worth mentioning because this is a real-world test, not a stripped-down best-case scenario. This is how people actually use their cars, inside the cabin. I've connected the Commander unit, which works alongside the Sexy Buttons ecosystem. Because of that, we're able to see detailed battery information that Tesla doesn't normally display. Right now, the battery is sitting at 73% state of charge. The battery temperature is at 31.3 degrees Celsius, which honestly surprised me. I expected it to be closer to 20 degrees, but it must have been much hotter earlier in the day. The net usable capacity on this battery is approximately 77 kilowatt-hours, from 100% down to 0, not counting the additional 3.7 kilowatt-hour buffer below 0%. That buffer is there to protect the battery and isn't accessible to the driver. This is a rear-wheel drive car, so we're only seeing data from the rear inverter. But the system still gives us a lot of useful insight. One of the nice features enabled by the Commander is enhanced visual feedback. When you brake, you see clear indicators. When you activate the turn signal, the system highlights it on screen. If there is a vehicle in your blind spot, the display turns red and shows it clearly, both on the visualization and on the side camera view. This isn't a built-in Tesla feature. It's enabled through the Commander hardware, which works alongside other sexy products. It genuinely adds a layer of awareness that feels like it should have been standard from the factory. For this test, we're using Tesla's built-in navigation. Normally, when I test Chinese EVs here in Thailand, I skip the built-in navigation entirely and rely on Google Maps because the native systems just aren't good enough. Tesla is a different story. The navigation system here is excellent, reliable, and accurate. So we're using it for the entire test. I've saved a specific turnaround point in the navigation system. We'll drive north slightly past that point, then turn around and repeat the route in the opposite direction. This creates a loop of roughly 33.6 kilometers. It's a good mix of road types and traffic conditions, and it allows us to get consistent data without elevation changes skewing the results. Before setting off, I reset all relevant trip data, so we're starting clean. The first test will be conducted at 90 kilometers per hour. On the display, that shows as about 92 kilometers per hour, which corresponds to an actual GPS speed of 90 we're using autopilot for this run to maintain consistent speed and minimize human variability. One thing worth pointing out immediately is the turn signal stalk. In the new Model 3, Tesla has brought back a physical stalk, and that makes a big difference. When I activate the turn signal while autopilot is engaged, The car changes lanes quickly and confidently. There's no hesitation, no awkward delay. It signals, checks the lane, moves over smoothly, and then centers itself again. The process feels natural and well calibrated. We're running autopilot on these roads just like we do in other vehicles. And so far, it's handling everything very well. Lane positioning is stable, speed control is smooth, and it reacts predictably to surrounding traffic. There's also a dedicated button that lets you instantly pull up the rear camera. If you swipe up on the camera view, you can switch to the front camera as well. What's especially nice is that the front camera has a washer system, similar to what we saw introduced on the Model Y Juniper update. That means even in dirty or wet conditions, you can keep the camera view clear, which is critical for both driver awareness and driver assistance systems. Now let's talk about ride quality, because this is something people often overlook when discussing efficiency. The suspension on this Model 3 is genuinely impressive, especially on Thai concrete roads, which are not exactly known for being smooth. This is the premium version, not the standard, and it comes with frequencies selective. Dampers. The result is a ride that feels controlled but comfortable. You can feel the bumps, but they're not harsh. They don't send sharp impacts through your spine. The car absorbs imperfections without feeling floaty. In fact, it reminds me a lot of the Leapmotor C10 that I tested earlier. Slightly firm, but in a good way. There's confidence in the chassis. The suspension never feels overwhelmed. If this were a pre-Highland Model 3, the experience would be very different. Those earlier cars were noticeably harsher, especially over broken pavement. This updated suspension setup is a real improvement. It makes long drives far more pleasant. As for phantom braking, which is something Tesla has been criticized for in the past, it does still happen occasionally. It's not completely gone. However, it's far less common than it used to be. During this drive, it hasn't been an issue, and when it does occur, it's usually mild rather than aggressive. As we continue along the route, traffic remains light, the car holds speed effortlessly, and energy consumption stays impressively low. This is where the rear-wheel drive configuration really shines. With fewer drivetrain losses and a lighter overall setup compared to dual-motor versions, the efficiency advantage becomes clear. Later on, we'll repeat a similar test at 120 kilometers per hour to see how efficiency changes at higher speeds. Aerodynamic drag increases dramatically as speed rises. So this will give us a good sense of how the Model 3 performs on highways where sustained high speeds are common. For now, though, the takeaway is simple. The Tesla Model 3 long-range rear-wheel drive feels refined, efficient, and genuinely well-tuned for real-world driving. The combination of the upgraded battery, improved suspension, excellent navigation, and mature driver assistance software makes it one of the most complete EV packages available today. This isn't just about chasing maximum range numbers on paper. It's about how easily and comfortably the car delivers that range in everyday use. So far, everything about this drive suggests that Tesla has quietly created one of the most efficient, long-range EVs you can actually buy and live with. As the kilometers start adding up, what really stands out is how little effort the car seems to be making. At 90 kilometers per hour, the drivetrain is barely audible, and wind noise is impressively subdued for a sedan in this segment. Clearly put work into sealing and insulation with the Highland update, and it shows most clearly at steady cruising speeds like this. You're not fighting the car. You're not constantly correcting. It just settles into a rhythm and stays there. The steering feel is another area where this Model 3 feels more mature than earlier versions. It's still light, still very much tuned for efficiency rather than feedback, but it's more consistent now. On-center stability is improved, and small steering inputs result in predictable, linear responses. On long highway drives, that matters. More than sharp turn-in or sporty weighting, energy consumption remains remarkably low as we continue around the loop. This is where rear-wheel drive really earns its place, with only one motor, fewer moving parts, and less parasitic loss. Car simply uses less energy to maintain speed. Combine that with Tesla's excellent motor efficiency and aerodynamic profile, and you get numbers that are hard for other EVs to match. Even years after the Model 3 first launched, Another thing worth mentioning is thermal behavior. The battery temperature has remained stable throughout the drive so far. There's no aggressive cooling kicking in, no sudden spikes in power draw from thermal management systems. That suggests Tesla's battery conditioning strategy is working quietly in the background, keeping everything within an optimal range without wasting energy. Inside the cabin, the experience remains calm and controlled. The family in the back is comfortable. There's no excessive road noise. And the suspension continues to do a good job filtering out sharp impacts from expansion joints and uneven concrete. This kind of composure makes a huge difference over long distances. It reduces fatigue, especially when paired with autopilot handling the monotonous parts of the drive. As we approach the turnaround point, traffic conditions remain consistent. There are occasional vehicles entering and exiting the roadway, but nothing that forces hard braking or sudden speed changes. Autopilot handles these situations confidently, adjusting speeds smoothly and maintaining safe following distances. After reaching the turnaround point, we reverse direction and continue the loop. This helps cancel out any wind or slight elevation changes, giving us a more accurate picture of real-world efficiency. Once again, the car settles back into its cruising speed without hesitation. One thing I notice on the return leg is how well the headlights perform. Night driving is where lighting quality really matters. And Tesla's adaptive headlights do an excellent job illuminating the road ahead without blinding oncoming traffic. The beam pattern is wide, even, and well-controlled, which adds to overall driving confidence as the kilometers roll by. It becomes increasingly clear that this car isn't just efficient in ideal conditions, it's efficient in normal use. With passengers on board, with real-world traffic, with imperfect roads, and with climate systems running, it still delivers outstanding results. Eventually, we complete the first loop and review the data. The consumption figures are exactly what you'd hope for from a car designed around efficiency. This sets a strong baseline before moving on to the higher speed test. Now it's time to increase speed to 120 kilometers per hour. This is where many EVs start to struggle. Aerodynamic drag increases exponentially with speed, and even small inefficiencies become much more noticeable. Once again, we reset the trip data to ensure clean results as we accelerate up to speed. The car remains stable and composed. There's no sense of strain from the motor, and acceleration remains smooth even as we approach highway speeds. Once locked in at 120, autopilot takes over and holds speed precisely. Wind noise does increase slightly, as expected, but it remains well controlled. This is one of the benefits of Tesla's low drag coefficient. Even at higher speeds, the car slices through the air more efficiently than many competitors. Energy consumption naturally rises, but not as dramatically as you might expect. The Model 3 continues to outperform many larger or less aerodynamic EVs in this speed range. This is where Tesla's years of refinement really pay off. Every small efficiency gain adds up when you're covering long distances at highway speeds. Traffic becomes a bit more dynamic at this speed, but autopilot continues to handle lane changes and following distances with confidence. When I signal for a lane change, the car checks blind spots, adjusts speed if necessary, and moves over smoothly without abrupt movements. The suspension remains composed even at higher speeds. There's no floatiness, no excessive body motion, and no nervousness. Over uneven pavement, the frequency's selective dampers adjust seamlessly. It's keeping the car planted while still absorbing imperfections. As the second loop progresses, battery temperature remains within a healthy range. There's no sign of thermal stress, and power delivery remains consistent. This suggests that even sustained high speed driving won't significantly degrade performance or efficiency under normal conditions. When we complete the high-speed loop and review the data, the results confirm what we felt behind the wheel. Efficiency does drop compared to the 90 kilometers per hour test, but it remains impressively strong for a car traveling at this speed with passengers on board. At this point, it's worth stepping back and looking at the bigger picture. The Tesla Model 3 long-range rear-wheel drive occupies a very interesting position in the EV market. It's not the cheapest Tesla you can buy, but but it might be the smartest choice for people who value range, efficiency, and long-distance comfort over outright performance by choosing rear-wheel drive. Tesla reduces complexity, weight, and cost while maximizing efficiency. The upgraded battery pack provides ample, usable capacity without pushing weight too high. The result is a car that feels balanced, predictable, and easy to live with. This version of the Model 3 also highlights how far Tesla's software has come. Navigation, accuracy, energy prediction, driver assistance, behavior, and system integration all feel more polished than in earlier iterations. Everything works together rather than feeling like separate systems stitched together. Another underrated aspect is charging behavior. While this test focuses on driving efficiency, it's important to remember that efficient cars charge faster in real-world terms because they need less energy to go the same distance. It means shorter stops, less time spent at chargers, and lower overall charging costs. For families, the practicality is better than many people expect. The rear seats accommodate child seats without issue. The flat floor helps with legroom. Storage space in both the trunk and frunk is more than sufficient for everyday use. From a cost of ownership perspective, this car makes a lot of sense. Lower energy consumption translates directly into lower operating costs. Reduced mechanical complexity means fewer potential maintenance issues. And Tesla's charging network adds an extra layer of convenience for long trips. As we wrap up the drive and park the car, the impression remains consistent. This isn't a flashy test designed to produce dramatic headlines. It's a calm, methodical look at how an EV performs when you actually live with it. And in that context, the Tesla Model 3 long-range rear-wheel drive quietly excels. It doesn't shout about its efficiency. It just delivers it kilometer after kilometer without demanding attention. That's arguably the highest compliment you can give to a car designed for daily use and long-distance travel. For anyone considering an EV primarily for range, efficiency, and comfort rather than acceleration bragging rights, this version of the Model 3 deserves serious consideration. It proves that you don't need multiple motors or massive battery packs to go far. You need smart engineering, good software, and a clear focus on efficiency. And after spending this time behind the wheel, it's hard not to come away impressed by just how well Tesla has refined this formula. The Model 3 may no longer be the newest or most talked about EV on the market, but in terms of real-world efficiency and usability, it remains one of the strongest benchmarks out there.